Let's take the design from the last video and we'll generate a 16-bit machine with it. Now, it's not rocket science what we have to do here. Everything that is 8-bit now has to be 16-bit. So if you head into the design and you head up to the top level, you can see here that we're going to have to go in to all of the content here. For example, the OR gate, and instead of it being 8 bits, we're going to have to, in effect, double this, so it's 16. And we have to go through every single part of the design and double up the number of gates from 8 to 16. So I'm going to go ahead and do this just now, and I'll come back and show you the final version. And again, you can go ahead and do this for yourself, or you can use this final version, which again will be in the resources section. So I've gone ahead and upgraded the CPU to 16 bits. It took me about 45 minutes or so to do the upgrade. Now you can see here in the top level, instead of having the 2 hex numbers, we've now got the 4 hex numbers. So this represents 16 bits. Each one of them is going to be 4 bits of data. So these are the 4 hex numbers. And you can see we've got R0, 1, 2 and 3 in the top, and we've got the bus, instruction address register and instruction register here on the bottom. We've upgraded the RAM, so if you click on the RAM is now a 16-bit RAM, so it means we've got in total 64 kilobits available. Now if we were to drop down inside the CPU and we just pick any one at random, we can see how it's been upgraded. So if we click on here and we begin to say, for example, the AND gate, you can see rather than have the 8 bits, we've just extended this to 16 bits. And we've done exactly the same with every other instance there. We've extended everything from the 8 bits to the 16 bits. So just pick one other one as an example, the adder here. And again, that's now a 16-bit adder. So it's relatively straightforward to change the design up to a 16-bit. Now that means we're going to be able to do a lot more things with that 64 kilobit of memory that we have. We can still use the same output from the 8-bit and load it into this RAM. So for instance, if I was to go edit contents and open up this file mysim, now this contains the Fibonacci sequence. So what I'll do is I'll leave a copy of this mysim in the resources section along with the 16-bit CPU, so you can go ahead and try it for yourself. Or alternatively, you can upgrade your own one and try out your own programs on it. So I'll open up this and you can see it's still opened up as normal. The only difference is that we now have the 4 bits available here, but the first 2 bits aren't used because we only have an 8-bit instruction. So we can close that, and then we can just put in simulate, and we'll pick a frequency, say we'll drop it with 1 kilohertz, and simulate, and we'll go tick enabled. And you can see the Fibonacci numbers are generated in R3, so that's 1, 2, 3, 5, 8, 15, and it continues up, but it uses the hex numbers. Now it'll continue all the way up as far as it can go, and then the program will stop. So let me just, well, that's the program stop now. Simulate, tick enabled. Now I've checked the Fibonacci numbers and it generates all the correct Fibonacci numbers apart from, and I just noticed this, the very last one. So 2511 is not a Fibonacci number, but the previous one to it is. So there's a little thing has to be sorted in the algorithm. So that's a good exercise for you. You can get and have a little look at the algorithm and see what's wrong. So it's obviously copying one number too many, and it's not copied the right one. But it does work previous to that, and it does create all of the Fibonacci numbers. And again, it's something I'll have a look at myself, and I'll update that algorithm. So that's a 16-bit machine generated, and we can do a lot more interesting things with this machine. But what we want to do is now have a look at the control section. So if we get into the control section here, you can see that it's a bit like spaghetti junction. So there's wires everywhere. And really what we want to do is we want to increase the number of instructions that we can generate. And also some of the instructions will become more complex. So for example, we would need more than these 4, 5 and 6. So we would have 3 fetch, but we might need more than 3 execute lines. So if we were to extend this hardwired control section, then it would quickly get out of hand. So we need some way of being able to increase the complexity and number of our instructions, but without an increase in complexity on the wiring. So that's something we're going to look at over the next section, and we'll have a few videos talking about the control section. And we're going to change from a hardwired control section to partly hardwired and partly a microcoded control unit. So that's all for this video. I'll get you on the next video. Goodbye.